In this video, we're going to describe what is meant by an alternating and direct current, look at the difference between them and how they can be used. Remember, an electrical current is the flow of electrons. Watch our video about current here. This is an example of direct current, or DC. Here we have a cell or a battery in a circuit. The current in a cell only flows in one direction, so the electrons only flow in one direction around the circuit. But be aware that by convention, current is a flow of positive charges, which is what you see here. The electrons which actually form the current are negatively charged, so they flow in the other direction. In this example, instead of a cell or battery, we have a mains power supply. The mains supply is an alternating current, or AC, which means the current constantly changes direction. The number of times per second the AC changes direction is known as the frequency, which is measured in hertz or cycles per second. The frequency of alternating current is different in different parts of the world. So why is our mains supply an alternating current? The main reason is because it's much easier to use a transformer to change the voltage of AC than DC. Transformers are used in lots of appliances to ensure that they have the correct voltage to work. Transformers are also an important part of the national grid, allowing electricity to travel along wires and cables efficiently. For more on the national grid, watch this video. We can see on this oscilloscope the voltage, or potential difference, constantly changing from positive to negative, and so driving the current in alternate directions. An oscilloscope trace for direct current would look like this. There is no change in voltage, so the current is also constant. So what about this oscilloscope trace? Is it AC or DC? What's the maximum potential difference? And what's the frequency? Pause the video for a moment to work it out. The trace is AC. We know this because the potential difference increases and decreases. The maximum potential difference is 200 volts. The frequency is the number of times the voltage changes in 1 second. We can see the distance between the two peaks on the graph is one complete cycle. This time is 0.02 seconds. That's the time it takes for the current to change direction and then back again. We can calculate the frequency like this. One cycle takes 0.02 seconds, so 5 cycles take 0.1 second, which means 50 cycles in 1 second, or 50 Hertz. So those are the differences and uses of AC and DC, and how we can interpret oscilloscope traces of current.